Today's video will demonstrate how to apply the Decorator design pattern to a real-world application, a chess program. Hello, I'm James Helfrich. Many of the algorithm abstraction and design patterns seem a bit, well, difficult to apply to a real-world application. This video will demonstrate how to apply the Decorator to a chess program, specifically how chess pieces move on the chessboard. I'll recall that a Decorator design pattern allows for part of an algorithm to be applied in any order or in any combination. We're going to have a decorator, which is an abstract class, and it's going to have a pure virtual function called task. And then we're going to have a concrete decorator, which is going to implement task, and which we can inherit off of decorator, and we're going to have several of these. Then we're going to have our component, which is going to have a list of decorators, and how many? Well, many. And I should be able to add a task, and then I should be able to perform the task, and this will go through all the tasks in the decorator. Now, our problem is chess, and we have a knight, which can move in an L-shaped pattern. We can have a pawn, which moves forward 1 or 2, or en passant, or promotion. We have a king, which can move in any direction, but it can also do castling on either king side or queen side. Then we have a rook, which can go backwards or forward or up or down. Then we have a bishop, which can go diagonally. And then we have a queen, which we can do diagonally or back and forth. Now, we're going to notice that the queen is just a function of the rook and of the bishop. And so we have a bit of redundancy here. Let's see if we can get rid of this with the decorator pattern. So now we're going to have a piece, and the piece is going to have a collection of move types, and the move type is going to have an apply move. Notice the piece can have many move types corresponding to the different types of moves it can execute. And so we're going to add a type like diagonal or up or down, and I'll be able to get moves as well. Now I'm going to have a diagonal, which is one move type, or back and forth, like for an example, the rook. I'm going to have an each direction like the king, and I'm going to have an L shape like the knight. I'm going to have an en passant, upon normal, upon double move, and then I'm also going to have some castling. So these are the different types of decorators I'm going to use. And so for an example, a knight will just have the L shape, and then the bishop will have a diagonal, and then the rook will have a back and forth, and then the queen will have a back and forth and a diagonal, and the king will have each direction plus a castle, and we have a pawn which can go normal or en passant or a double. But notice that after a pawn has moved a single time, then it can no longer do double, so we'll remove that off our collection of possible moves. All right, let's do a demo now. Okay, so here's my piece class, and my current implementation has a get moves, but what I want to do is add a list of move type. So first of all, I have to pound include list. I got that. And then I'm going to say, as a protected, I'm going to say, okay, now I've created my decorator class called move type. It's going to be an abstract class with a pure virtual function called get moves. Now I'm going to implement one move type, and I'm going to implement the knight. Now, as I do this, the first thing I'm going to do is create my L-shaped class. And then I'm basically going to copy the code that I used to have in my knight get moves. There's a little bit of difference I have to make because I have to pass a position rather than have it as a member variable. But other than that, a little bit of refactoring, it should be really straightforward and work exactly the same. Okay, so now we have basically copied over the code from our old knight get move into our new one. We had to make some adjustments here, so we had to pass the piece in because before it was a member variable of the piece, and now it's not. Now it's a decorator. It's not hooked up right now, so it should work exactly the same. We're going to compile to make sure everything works correctly. Oop, and it does, good. Now we're going to connect it, so my knight is going to call my L-shaped get moves rather than its old version. Okay, so now that we've implemented this, we're going to hook it up, and we're going to see if it works. And notice that my knight unit tests all pass. Therefore, my new decorator works. Okay, let's do the same thing for the other pieces. Now, as we do this, it's basically the same I did before with the knight. I'm just going to take the code that used to be in my bishop get moves, my rook get moves, and I'm just going to put it in this new format. It's just a bunch of refactoring, but the logic is going to stay exactly the same. In other words, I'm not changing any functionality, but rather I'm moving it into a different location so that I'm going to have a generic interface that I'll be able to then use in a list of gen moves to apply the decorator pattern. Okay, let's see if I made any mistakes. We're going to run it again. I have my rook, bishop, and knight now hooked up. Build succeeded. And yes, all my unit tests still pass. I'm doing well. Okay, now we're going to do the queen, and the queen one should be interesting.
I don't have to create a decorator, I just have to hook up the bishop and the rook's decorator. Isn't that easy?
Yep, and my queen worked. That's awesome.
Okay, now I got to do next is the difficult one, the pawn. And the pawn we're going to break up into three different decorators, the en passant, the normal move, and the double move. And all that was in a huge function called pawn get moves, but now I'm going to break it up into three separate ones for the separate classes. I'm also going to do the same thing for my king, for my castling versus my normal moving. This can require moving a lot of this code that used to be in my king : get moves and my pawn : get moves into their respective decorators. And there's going to be 5 of them this time. So quite a lot of code churn here. But once again, my new king.get moves is just going to call the king 2 decorators, and the pawn : get moves is going to call the pawns 3 decorators. So the functionality is going to be exactly the same. I have not yet implemented the decorator design pattern. I've just refactored it so I can implement the design pattern in just a minute. Now, of course, the trick here is to make sure I don't make any mistakes and get it right the first time. And I had a couple of compile errors, but they were pretty easy to fix. So let's see how it goes.
Okay, so all my unit tests still pass. I've refactored everything, but I have not yet done the decorator pattern. While I've changed all the move code so it's in its own separate function, I've not yet put it in a list. So now it's time to do that.
Now remember, I have these 6 individual concrete decorators. So what I'm going to do is in the constructors of each individual piece, I'm going to add them to my moves list. I'm going to push back pawn normal, pawn double, en passant. In my rook, I'm going to push back my diagonal. In my knight, my L-shaped. In my queen, I'm going to both my diagonal and back and forth. And now my moves list will be populated.
The last thing I'm going to do is I'm going to change get moves in my piece base class to no longer be virtual, but now what it will do is just run through every element in my moves list and apply them.
So now each piece, when it wants to get its moves, is going to iterate through all its move decorators and then add them to my set of moves. Now observe, I could actually change the functionality of the piece by adding on a diagonal to a pawn if I want, or a castling to a rook. It's totally easy to do. I can do it dynamically, and that's the big win of the decorator design pattern. It's super easy to refactor.
So my unit test pass, I have my decorator design pattern working correctly.
Okay, so let's take a look at what we did here. We have 8 concrete decorators. I applied them to the individual piece at the piece's construction time. At the piece's get move, it's going to iterate through all the decorators in its list. It might be 1, it might be 2, it might be 4, and then it's going to fill up our set of possible moves list, which is what we're going to return.
You can learn more about this in the decorator section of the algorithm abstraction chapter of the software design textbook.